Hello dear student, welcome in KIT Arts, BH Commerce and AM Science College Nasik. Student, myself VS Shinde, Assistant Professor in Department of Chemistry. Student, in previous lecture we have seen two electron transfer reactions and complementary and non-complementary reaction. In today's lecture, we are going to see substitution in trans complexes as well as cis complexes. So let's start. First of all, let's see substitution in trans complexes. So let's take first example of trans complex. Example is trans M. M means central metal atom, central metal ion. LL2. LL2 is nothing but bidentate ligand. For example, EN, that is ethylene diamine. It is bidentate ligand. So let's see about this example, trans M LL2BX. LL2 is nothing but bidentate ligand. B and X are the monodentate ligand. Okay. So the substitution in trans complexes proceed through three different pathways. If we are going to take this example, that is trans M LL2BX. In this complex, if we are seeing substitution, it proceeds through three different pathways. So let's start with first pathway. If we are write this complex, if we are draw this complex like this, these are the LL means bidentate ligand, B monodentate ligand, this is your central metal atom or ion, and X, this is also monodentate ligand. Okay, see here geometry is trans geometry and the complex is M LL2 B and X. Okay, so if dissociation of X from the reactant species, this is your reactant, and if X is dissociated from this reactant, it leaves a square pyramidal intermediate. Obviously, if X is dissociated from this complex, we will get square pyramidal intermediate. Okay, this is your square pyramidal intermediate. Okay, student. So, it is now easy to add this incoming Y ligand. Okay, then the new ligand directly add into the vacant site. Okay, if Y is added here, what will we get? Retention of configuration as your starting material. This is your Y. This is your retention of configuration in first pathway or in first case. Okay, what I explain here, if this is your trans complex, if X is dissociated from this complex, we get square pyramidal intermediate. Then when we add incoming Y ligand in this square pyramidal intermediate, we get retention of configuration, that is the product as it was like a reactant. Okay, only Y is added here. So this is our first possibility. Okay, let's move towards second possibility. If you draw your complex like this, this is also trans one. Okay, so if we are draw a trans complex like this, and if X is dissociated from this complex, we get trigonal bipyramidal intermediate. What we get? Trigonal bipyramidal intermediate. This is very interesting intermediate. We get here trigonal bipyramidal intermediate. Okay, so this is your trigonal bipyramidal intermediate. If you draw trans complex like this, means a trigonal bipyramidal intermediate with B in the trigonal plane which gives mixture of cis and trans, which gives mixture of cis and trans, means here again three possibility of product. How? This is your trigonal bipyramidal intermediate. Okay, if I just draw again three complexes, means three intermediate for your understanding. See, now see, in first case, Y attack from this side. In second case, Y means incoming ligand Y attack from this side, and in last case, Y can attack from this plane or this side. Okay, these are the three possibilities for your product in case of trigonal bipyramidal intermediate. This is very interesting intermediate, and we get from this mixture of cis and trans. Okay, so how it, let's see. If Y attack from above side or above plane, from this plane, we get cis product. We get cis product. Okay, this is nothing but means B and Y at the cis position, so we get cis product here. When Y attack from this side, again we get a cis product. We get cis product. Okay, but when Y attack from this side, now in this case we get a trans product. Okay, means in case of trigonal bipyramidal intermediate, we get mixture of cis and trans product, while in case of first, this is case first or possibility first, this is possibility second. In case of first possibility, when X is dissociated from this complex, from trans complex, we get square pyramidal intermediate, and when Y attack on this complex, it gives retention of configuration at it was your product, reactant. While in case of second possibility, when X is dissociated from this complex, we get trigonal bipyramidal intermediate, and in this case, for this intermediate, Y can attack from three ways. When Y attack from this plane, we get cis, while when Y attack from a lower side, we get cis again, and when Y attack from this side, we get a trans product. Okay, so here is mixture of cis and trans, while in last case, that is when B at axial position, when B at axial position, this is the last case or third possibility. This is also interesting one. When B is at axial position, again we get trigonal bipyramidal intermediate, but it less likely we get a trigonal bipyramidal intermediate when B at axial position and when X is dissociated from such complex, or from such geometry. This is your trigonal bipyramidal intermediate, but it less likely possibility. Okay. In this case, there are again two possibility of product. Here, two possibility of product. C, B. Okay. C, Y can attack from this plane. Again, Y can attack from this side, but the back side or this plane is totally blocked for this attack. Okay, so Y cannot attack from this side. So only here two product we get, which are the cis one. Okay, if we are write here product Y, B, here is your cis product because B and Y at the cis position, and again Y is here. This is also your cis product. Okay, means this is the third possibility. When B at the axial position, it gives less likely trigonal bipyramidal intermediate, but in this case there are only two possibilities for incoming ligand. When Y attack from above side, it gives 6. When when Y attack from this side, it again gives a cis product, but this side is totally, or this plane is totally blocked for attack of Y. So here only we get two product, that is two cis product. These are the substitution in trans complexes. When your complex is trans, we have seen three cases. In first case, we get retention of configuration. In second case, we get trigonal bipyramidal intermediate, and there are three possibility for product, that is the mixture of cis and trans. Y attack from above plane or above side, below side or below plane, and from back plane, okay, or back side. So we get mixture of cis and trans. And when in third possibility or in third case, when B at the axial position, it gives only two product, that is a cis product. Okay student, so let's see substitution in cis complex. Substitution in cis complex, it is somewhat similar with trans complex. Here is again three possibility. So let's see substitution in cis complex. I directly draw here complex. Okay, this is your first possibility. This is your complex, that is a cis complex. Substitution in cis complex can proceed by the same three intermediate as it was in trans complexes. Okay, means substitution in cis complex can proceed by three same intermediate as it was in trans complex. Means square pyramidal, after that trigonal bipyramidal, and less likely trigonal bipyramidal intermediate. So let's see when it's when X is dissociated from this complex, we get the intermediate. Okay, when Y attack on this complex, we get again a retention of configuration. Okay, this is your product, means retention of configuration. Okay, so this is your square pyramidal intermediate again, and when Y attack on this complex, we get retention of configuration as it was in reactant one. Okay, so let's see second possibility. Let's see second possibility. B X okay, when X is dissociated from this complex, we get trigonal bipyramidal intermediate B at the plane. This is your trigonal bipyramidal intermediate. Okay, again here is possibility for three complexes. Here possibility of three complexes. B, this is your square pyramidal intermediate. Okay, now see, in this case when Y attack from this plane, again Y attack from this side, and lastly Y attack from this side. Okay, so in this case when Y attack from this side, here we get trans product. Okay, when Y attack from this side, again here is cis product, and when Y attack from this side, we get cis product. Okay, means again here we get mixture of cis and trans product as it was in substitution in trans complexes. Means in case of this, when your geometry is like this or arrangement is like this, we get trigonal bipyramidal intermediate after dissociation of X. Again there are three possibilities. When Y attack from this plane, we get trans product. Y attack from above side, we get cis product. And when Y attack from back side, we again get cis product. Means here we get mixture of cis and trans. This is your second possibility. And let's see third possibility, in which again B is at axial position. This is your last possibility, that is third possibility, when B is at axial position. In this case, B is at axial position. When X is dissociated from this complex, we get trigonal bipyramidal, less likely trigonal bipyramidal intermediate, where B is at axial position. Okay. In this case, again there are two possibilities. Either Y attack from this side or Y attack from this side. I directly show here. And one side is totally blocked for attack of Y. So when Y attack from this side, we get cis product Y, we get directly cis product. Okay, and when Y attack from this side, here we get B, sorry, Okay, in this case, when y attack from this side, we get this product. Okay, student. So these are the all possibilities for substitution in cis complexes. So in today's lecture, we have seen substitution in trans complexes. There are three possibility. In first case, we get square pyramidal intermediate. After that, in second case, we get trigonal bipyramidal intermediate. Again, there are three possibilities for product, and in third case, when B at the axial position, we get two product. Okay, while in case of substitution in cis complexes, in first case we get square pyramidal intermediate. After that, in second case, we get trigonal bipyramidal intermediate, and in third case, when B at the axial position, we get less likely trigonal bipyramidal intermediate. In this case, again we get two products. Okay, student. So thank you. In next lecture, we start our next section, that is photochemistry. Okay, students. So thank you.